A research team, led by Dr. Hart, sits around a sunlit conference table. Each member has their laptop open, data files scattered across the table, and cups of coffee growing cold. The project: to determine the effectiveness of a new intervention in reducing post-surgical complications. But before any subject is recruited or funding is granted, one crucial hurdle remains: justifying the study's sample size. Dr. Hart, aware of previous reviewers' critiques, addresses the team. Why is it essential? She explains, a too small sample might yield inconclusive results, while an unnecessarily large sample wastes resources and might even be unethical. Striking the right balance is key, especially in a funding application where reviewers often focus on whether the calculated sample size is scientifically justified. The biostatistician, Marco, joins via video call. He shares his screen to walk through the sample size calculation process. First, they clarify the study hypothesis. The primary endpoint is a reduction in complication rates from 25% to 15%. They agree on an alpha of 0.05 for statistical significance and a beta of 0.20, an 80% power to detect a difference if it exists. Marco opens his software and selects the appropriate statistical test. For their binary outcome, he chooses a chi-squared test for two independent proportions. The software prompts for effect size, baseline event rate, 25%, expected event rate with the intervention, 15%, significance level, and desired power. The tool spits out a recommended sample size of 340 subjects per arm. The team pauses. Ellen asks if they should inflate the sample size for potential dropouts. Marco recommends estimating a 10% attrition, suggesting they round up to 380 per group. Another team member wonders if multi-center participation will require adjusting for clustering effects. Marco agrees, citing the possible need for an intra-class correlation and a design effect adjustment. They draft the funding application to clearly describe each parameter and assumption, anticipated event rates from the literature, rationale for the difference considered clinically meaningful, statistical parameters, power analysis, expected attrition, and design adjustments. Ellen pens a summary emphasizing their stepwise, evidence-based planning and willingness to revise estimates should new information arise. As the day ends, the group reviews their work: robust, transparent, reasoned. Dr. Hart smiles. Their application, with its clear sample size justification, will stand out not just for the project but for the rigor underpinning its science.